So it works on my machine. This is, I don't know, you said victories, not so much. These are lessons about what not to do. Some of them are a little bit older and maybe not quite as relevant, but some of them are timeless, and all of them are just extremely nuts. I've been around in the industry for a couple of decades now, so I hit the 30-year mark already, and at this point, I think I've seen it all. Of course, every time I say that, somebody shows me how I did not see it all. And right now, I'm at JetBrains as a developer advocate. The only other real job I've had in the past couple of decades is Microsoft, and other than that, I've been a consultant, an independent consultant. And both Microsoft, JetBrains, and as a consultant, you're out at clients all the time. And at everywhere I went, I saw dysfunction and people just doing crazy things, and me shaking my head and saying, well, I know why I have a job. It is to come in here and clean up after some of this stuff. And I know everybody else has to deal with this at some level, maybe not some of the extremes that you'll see in here, but it should give you a little bit of hope for the future. And you get to see you're not the only ones with this kind of dysfunction. It is a bit of a lighthearted talk as well, so I'm going to be doing quite a bit of joking about a lot of the stuff that I've seen, and telling you, of course, the thing that you should do instead of the thing that happened. Sometimes I won't even need to explain that. It is pretty obvious, except to that one person that one time. So that's what we're going to talk about today. Here's one thing that happens, right? Testing in production. I don't think I need to even say, like, don't do that. We know we shouldn't, but there's somebody who likes to do that anyway. And I knew a lot of people who've done this, right? Testing right in production. But so this talk, this is all real. Every single one of these things happened, and almost every single one of these things happened on a project I was on or at a company I was at, consulting at. So it's all about these failures, but it's anonymized. So if I was at your company or whatever person, you're not going to see names. And at best, I'm just going to give you the industry and, a few things like that where you can't really tell where it was. You shouldn't be able to. So this way, I'm hopefully not embarrassing anybody in particular, but able to teach you a few lessons anyway. So let's start, of course, with the familiar train wrecks and Titanics. We'll do this with the database, right? Because we all work with databases, and even though stuff nowadays like graph databases and object databases and Cosmos DB is all the rage, relational databases are still a workhorse, and they're still out there being used. And I've seen some utter horrible things happen with databases. I've done a little bit of DBA work as well as development. And most of my stuff has been on the Microsoft stack. And database is one of those things. Let's take a look at some terrible things that happen. So if you have a table in a database, you might expect it to look something like this, right? I have maybe a customer or an employee or something. ID, name, address, city, state, zip, columns in a table, because in a relational database, generally that's how we split things up. We have these fields. We'll take one of them, usually that ID field, we'll make it a nice little key, and from that we can create indexes. It's easy to search, it's easy to work with. But what if I told you there was a managing supervisor at it was an American company that did automotive stuff, and it was a very big nationwide company. And this person took perfectly normalized databases, and even before I got there to clean this up, made the team roll them into one column per table. And that column would have basically the first couple of fixed width characters as the ID, then the next as the name, then the next as the address. So it ended up being one column to roll them all. And all of the tables ended up being like that. And then when I got there, this person said, I don't understand why it's so slow. I don't understand why things don't work. And I was like, you don't, really? You don't? So I said, and he goes, well, you know, the indexes just must not be working. And I said, indexes? Like, how do you even have an index on like one column? I mean, at some point, SQL, this was SQL Server. So at some point, SQL does actually have to create a clustered index, which is the physical arrangement on disk. And it's going to be that whole column. So this is just massively just awful. So this person essentially took a relational database and turned it into an ISAM database, which is where he came from. So all of the stored procedures, they don't work anymore. So what they had to do is they'd have to take all of these, and because they're fixed width locations within one column, they'd have to be doing pat indexes to get where this one started, the next one stopped, trimming all over, character index, substring. So procs all just had a whole bunch of string manipulation, which is also not exactly the most efficient thing to do. So of course you can't get any kind of non-clustered indexes or any of the good performing ones. You just, things are just slow and terrible. So this is an easy one. Like, just don't do this, right? Do not make one column per table. Actually have a column per field. Other things that happened with this. One of those columns was a 20 character wide column. It was a fixed week, not even a var char, just a char. And the last three weren't used yet. And what it was for security. This was the security on this system. There's one column in a table called security. And the procedure would have to read this in, and you would have to know that, say, position number 5 was to get access to these other tables. And position number 7 was actually maybe access to a resource on a website. And it was just pulling out a bunch of Y's and N's that were about 17 characters at the time, because they didn't get the other 3 in there yet. Those were a little buffer in case they added more security features. So it was all a flag, and it was just ripping apart this one column. Now, first of all, operating systems and databases have security built in. And the programs, software that used these databases was .NET. It was, some of it was earlier in web forms, and some of it was later with MVC and whatnot. But nonetheless, it was all, a couple of Windows forms for internal stuff too. But it was all .NET stuff. So, they're using Windows. This is running on Windows boxes. You have things like Active Directory. You have things like identity in ASP.NET. You don't need to do this. And even if you did have to roll your own security, this is not exactly the easiest way to do it. So it's the same stuff again, going through and just finding a location and hoping that that is right, and then allowing access to resources based on that. So don't do that. That's not good. Also, why doesn't our security seem to work so well? That's why. You can use the resources that databases and operating systems have. Here's the thing, there's a lot of smart people that built SQL Server, and they built a very good product, and it does its job, and it does its job really well. You don't need to try to redo its job for it by doing this thing with the columns and security. You can actually use SQL security and role-based access and things like that. You don't need to do this yourself. So when you have those options built in, take them, because it's going to be better and more bug-free than what you have. It will not necessarily be free of bugs entirely. There's no such thing as software that does that. But rather than recreating it yourself when you're not a security expert, you probably don't want to do this, right? You just want to go with the security that they have. So these were pretty egregious. This is the only time I've ever seen somebody do this. Like, they turned SQL Server into an ISAM database. I said, at this point, you might as well be using text, just using text files, because it's about the same. More on databases at a different client. Somebody did not like them, thought they were too slow, and thought, well, why don't we just save the data in RAM? RAM, yes, you're using that word. I don't think it means what you think it means. Because, you know, if you save in RAM, what's going to happen? Like eventually, that's going to go away if the server gets shut down or something. So a CTO actually believed that databases in general are too slow. Didn't matter what kind they were, what vendor, anything, they're all just too slow. So the data should just be stored in memory. Not a CTO not realizing that that's not how you do data. Right? So you do some temporary data, sure, but not your actual data that you need to permanently store. So he told those devs to store everything in memory. And they already had databases, so this would have been like reworking some of the stuff. And they had a lot of stuff going on. Hundreds of objects in memory and structures for those and all the relationships and everything. So what people were doing, you know, you're talking a couple of gigs of RAM, and to work around this new mandate that these people had, they had to serialize everything to binary and then pulled it in as a blob into a SQL database. It's hard to say which is worse, this or the whole SQL as an ISAM database thing. I mean, here you actually have to go through the extra bits of code to read it out with like a binary reader. Yeah, don't do this either, right? Again, this is another one. Databases are not just too slow, right? If a database is a little bit slow, you can change that, right? You can go in there, you can adjust RAM. You might actually need some new hardware or an upgrade. But there's a lot of performance optimizations that a good DBA could do. And it's most likely that they just simply didn't have proper indexes. And actually, that is what it was. They just didn't have proper indexes on what they had beforehand that caused the CTO to have them start changing everything around to do this. And I just took one look at this, and this is another one where I thought, oh, this is ridiculous. Like the only word that comes to mind is ridiculous. I would never, ever come up with this myself. What I say is if a database is slow is, well, let's look at why. Not just they're too slow, let's just do this whole new thing where we move the data over, put it in RAM, and just make random things up to do. That's just not the way to approach things. So you can again take advantage of what the database has to offer, and if you do it correctly, it can perform quite well. So you shouldn't really have problems there where it is too slow. And really, the CTO could not actually define too slow either, just that it was not as fast as this person wanted it. But I sort of feel that as fast as the fastest jet on the planet would not be fast enough if this person were going somewhere. So it doesn't, you know, certain things are just kind of a thing where you can't please somebody. But they did end up fixing this and going back out and taking that, moving back to a regular database structure, at least here. That first example, that software ran for a long time, just like that for several years. It was very painful to deal. Every time you had to modify anything, it was just, it would break everything. It was awful. So this is also why consultants cost a lot of money, just, you know, because of these kind of things. I used to live in Pennsylvania when I was in the US, and one of the clients there that did processed some of the tax stuff. So, you know, government at work. So they had stored, they actually had this really nice application, and it was built out the way you would see in like a patterns and practices type of a book. You know, you have your end tiers. It was C#, MVC, in maybe around MVC3, somewhere around there. And the C# part and the MVC part was really good. And it got to the part to where they called on stored procs. And up to that point, it was great, except for when you started to actually read into a stored procedure. And again, performance was an issue here. When they got to that stored procedure, I started tracing for them. And I'm like, okay, this one calls this stored procedure. Okay, so there's a nest. And here's another nest. Here's another nest. Here's another nest. I stopped when I stopped at some of them when I started counting up to 17. and one of them I found 23 in. Let's just say no, that's way too many. Like, just like with functions or any programming construct, you can only nest so far because before it is literally impossible to just follow. Like, I got to a point to where I physically got so tired I could not even follow the nesting. And I said, well, here's your problem. I said, this is just too much. And their database structure was actually pretty good. So everything around this one block of stored procs that had this super nesting thing going on, everything else is actually pretty good. And I said, well, what we could do is take this block of procs that is causing some problems, and we can get the data from your, nicely set up tables that are normalized. They have columns, they have indexes, that stuff is all done well. You're using all the patterns you should. Everything else is good. It's just this one little set for this one particular part of the program. I said, well, we could just rip these out. We'll start ripping these out and rewriting them as a proc that is not nested like that. And we'll see how we could do that. So that's what we did. We sat there with the team and went through and unnested them and took advantages of joins and things like that instead of doing those little nested procedure calls and stuff like that. So once in a while, nesting 1 or 2 levels is not a problem. But once it starts getting to be too many to follow, it's just too many to follow. So just watch this. Yeah, so none of these are good. So they're, yes, drunk procedures. Here's another one. Here's another good government one. So this place made like shells and some military equipment, that you fire at enemies, that kind of stuff, like big bullets and whatnot. And what they did was they had a bunch of different disparate systems, and they had to tie them together. So they did have pre-approved commercial software that ran on SQL Server and some that ran on a different SQL Server when you do the installations. And you just needed to get data in between those two databases, which is generally not a problem. You can actually just create some procedures and use like a SQL job to run on a timer and just exchange the data once every evening, which is what they needed. That's what I ended up doing for them. But what they had first was, these two databases that they needed to exchange data with. Actually, nowadays I would use Azure Functions for this, but back then it was just basically SQL was it. So instead of just going database to database through procedures, somebody, their IT person who was not really a programmer, but he was good at access, decided that he would designate a machine. And this machine had multiple access databases on them. And the databases would draw down records from the database. And Access being a jet database can only do, I think it's like 200 at a time or something before it has to chunk it. It's really interesting. So it would do that and then process some of the data with little macros and little, queries and stuff like that in the Access database. And then it would push it up to the other database. And this machine just sat there running all day, and that's all it did. And these Access databases were not the best. So sometimes they would just go down. They were running like every like hour. Like the first one would run every hour. The second one would run maybe once a day. The third one would run every, whatever the timer was. I forget exactly now. But sometimes they would just go down for no reason. And then you just have to go and figure out which one it was. And based on looking through some of the logs that they created in a little temp table in the Access database. And then you'd have to go in there and reset it. And it was basically just little screens with a button, just one button. You click the button and then it would just say it's running, and that's what it's doing. And this is kind of not necessary, right? So, and the thing is, if somebody lost the password to this, they wouldn't have access to this, right? So, or if that IT person wasn't there and one of these went down, nobody knew what to do. Right, so they always had these weird little problems with this. They just kept creeping up, and they said, "What can we do about this?" They said, "We can get rid of that whole machine. We'll just put it in some sort of procedures, set it to go on a job at the timing that you need, and you're good." So Access is great for a lot of things, but moving data between SQL databases is probably not the thing I would choose to do with it. So this is probably not the worst thing I've seen either, but it was rather amusing to me though. So people do anything with Access, really, and Excel, anything. So a select into is pretty darn easy. And of course, you can even add in some business rules and stuff like that. You don't need a bunch of databases in a dedicated machine. Onto code. So comments, let's start with some just fun comments. So these are not complete train wrecks. These are just hilarious things I found in code over the years. So stuff like that, eat me. I like the threats in code. Somebody's getting punched. My favorite, the hammer time one. Or I worked at a place where they did a little contract in Texas, and they did some work for law enforcement there, doing like videos and stuff like that. And this one developer, all throughout the code base, you would constantly find comments that just simply said cheese and more cheese. And like the first week there, you know, I kept running across these cheese, more cheese, and you see these comments when you first come on and you're looking at a new code base and you're like, what the hell is this? Especially when it has nothing to do with cheese. So then I asked one of the people on the team, what is this? Oh, well, that's, you know, so-and-so. That's what he does. Oh, okay, why? I don't know. It's just always been like that. You go over and you ask him, he goes, well, this cheese means blah, blah, blah. And when I say this cheese means something else. And it depends on what exactly was commented out when it said cheese. And I'm like, so it's this weird, like, cheese code. Like you needed like a cheese decoder for this. And I'm like, okay. So there is a time, like a lot of people say things like, code should be self-commenting. Definitely better than this, right? Like no comments are better than this, right? Maybe not the hammer time one, that's just fun. But stuff like that is just, it does nothing but confuse, right? At least saying whoever wrote this is getting punched, you kind of get the feeling that somebody did not like your code fine. And there are times when people eat exceptions and at least they're messing up, right? But then the cheese thing, it makes no sense and it confuses. And if a comment confuses people and it doesn't actually add to the code or explain what it's doing, and you need to ask like 3 people to figure this out, it's not a good comment. That's my favorite. Should the following commented code even be commented? Now, this is an issue with comments. Very often, you come across comments that actually are somewhat poignant, right? It says, well, this code, blah, blah, blah. You have those comments. But you actually just come across blocks of code that are just commented out, like not an actual, I left a comment for the next person, but just a block of code. I'm just commenting this block of code. The next person who comes across that code has no idea. Do you look at that every time and go, should this be commented? Why is this commented? Was this working at one time? Right? It just starts that little doubt cycle with whoever did not actually do the commenting. So that's why I say just delete code, right? You have source code control, and I have some spectacular failures with that coming up, but you have source code control. So just delete it and then check that in and you'll be fine. You can undo it. And so that the next person that comes across this does not have to make a comment saying, should this code that is commenting actually be commented or should it still be running? Because you'll never know. And I never actually did find out about that one. Another one, if you know what this code does, please fill in the comment section. So somebody wrote some code and was like, screw you, go figure it out on yourself. That's my favorite one. So you know you did something terrible. During fix later is actually probably more explanatory than most comments that you see as well. And then another one, like once in a while, you just get shenanigans programmers, right? So they may rickroll you in the code. That does happen. Not a failure, just fun at that point. Okay, from comments to anti-patterns. So anti-patterns is like a fun topic for me because it is often these solutions, it's just like the one column data, one column table and a database and everything else. And the solution actually results in dysfunction. So it's not a pattern, because patterns help us and they help us keep things consistent, which is my most favorite thing in programming, consistent. Even if it's consistently a little bit on the crap side, I can deal with it because it's consistent. But if it's not consistent, it's just awful. So an anti-pattern is just a solution, but it results in dysfunction. So we have a lot of those. And technically, I guess everything up to now would also be considered an anti-pattern, but we do have some more. I saw this at a client. Called me and they said, we just want guidance. We're not having performance problems, which I get a lot of that. But we just are starting to find that the code doesn't really feel as manageable in this project as it should be. Okay, so I go in and they say, look, we're trying to adhere to patterns and doing all the conventions and stuff, and we're following solid. Oh, this is great. I'm like, oh, this sounds great, right? I'm like excited about this. This is not going to be a train wreck. It's going to be an awesome client. And they go, yeah, so let's start with, S. How about single responsibility principle? This is really important for us, right? We know that, every class should have a single responsibility and blah, 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 and all the things about SRP. So they knew this, they knew the definition, they could recite this, they knew what it was. But how they implemented it was a little bit like extreme single responsibility principle. Because here's what they did. They had a solution, and each project in the solution, which was over 80 projects, there's 83, I believe, and each project had one and only one class in it. And that class did one and only one thing. Now, they did adhere to single responsibility. They did, like, so much so that this was how this came about. So they had one class in one project and repeated that out. And they said, it just feels like this is a little bit much ceremony. And I'm like, yeah, I think it is. So we were able to take those and find ways to just logically, this was an easy one, right? You could just logically take the classes that are related and group them into projects to make libraries, instead of having to have one project, one class that compiles out to one DLL. And then you have to have 80 plus references in other projects that use them. So that was a kind of an easy one and very amusing for me that somebody was like, we are so focused on single responsibility that we took it to this level. Okay, I've got to say, at least they were trying to do the right thing and trying to adhere to the patterns, even if it ended up in an anti-pattern. And it was not a hard fix. And they fixed it up, and then things were really great, right? So it was pretty easy for them. They just got a little carried away. And, we're programmers, we do that sometimes. Another one too, similar. There was a large company, it was an insurance company, and they tried putting every project that they could possibly think of that this one team had into one Visual Studio solution. And, this is great if you're a small company and you only have a couple of projects, but at a big insurance company, it's probably not going to work. Not only that, this first app may have nothing to do with the next app. So why? And they said, well, when we load up Visual Studio, it takes like 10 minutes and sometimes it times out. I'm like, what? What do you mean? Show me. So they try to run it and it takes forever to load. And when it does load, there's projects everywhere. So that was an easy fix too. Like, why don't we just not do that? Why don't we just logically group projects together into different solutions, sit down and map this out on a whiteboard or paper and figure out what belongs with what, and break these up into smaller, more manageable components. So as you see, consistency and modularity make things a lot easier. So that was the, project anti-pattern, trying to just cram everything into one solution. That's not how the solutions work. Here was another one. It's kind of back at the code level. I had mentored a senior developer who was writing some ASP code. It was actually like classic ASP system scripting. And they had to create a table. And they did the 2 headers, and then they had several rows and like maybe 2 columns. It might have been more, I don't remember exactly. And this page had thousands of lines in it because almost all of those lines was just a classic. Code was copied to create one cell in the table, and then that same code was copied except to say where the cell should sit. Right, that was the only difference, and copied and copied and copied. And this was somebody who had the title of senior developer, which really blew my mind. That I said, well, this code could be more manageable for you if you simply took all this code and condensed it into a function and just called the function from where you need that output to be. And this person said, a function? What does that do for me? I was like, I'm looking around for the camera because I was like, you're kidding, right? So this was supposed to be the most senior developer on a team. And I was like, you're kidding, right? So I had to teach the senior developer what a function was. And it took him a while, and he still was a little leery of it, but did end up going through and making it into a function that could accept a couple of arguments to say where that item should be rendered in that page. So that was another amusing one. Yeah, so functions are your friend, right? Modularity is your friend. Don't copy and paste code. Once you start noticing that happening, that's an anti-pattern. So you can take any kind of copied code, like a 3 times you're out ruled. All right, if you want to copy it for 2 headers, fine. That's not the worst. But once you get to 3 or more, don't. Condense it into a function or some kind of modularity, some kind of module that you have, and be able to call it over and over again. Here's a gem. This one gave me a lot of grief. I was at this place consulting for a few months, and then I became an alcoholic after that, I'm pretty sure. So this was in the land of web forms. The only time I've ever seen this particular thing. So in ASP.NET Web Forms, back in the day, what you would have is this model where you would have this web form, and the file had a .aspx extension. Many of us are familiar with web forms. And this is where you could drag and drop controls. And all the ASP.NET people would argue, should you be dragging and dropping? Do real programmers do such a thing, et cetera, et cetera. And they have the web form. And this particular development managers had set up the team and the project so that there's one web form, and in this web form there's only one control, and it was a content placeholder. Right, so that basically generated, I think it was a span or a div, and that was it. So instead of taking all those little controls that you drag and drop from the toolbar, or even typing them in or doing whatever, there's just one and only one control on that web form itself. But in the code behind, which was at 120,000 lines when I first saw it, and they added like another 30,000 to this thing at some point. What it was the web form.aspx. Oh, it was VB too, but VB was not the problem here because they would have done this no matter what the language. The code behind, which is your class. So the class had 120,000+ lines, and all that it did was it started with that content placeholder and did a placeholder.controls.add. And then once they would add a certain control, maybe to create a div, then they would go to that div.controls.add, and it just dynamically built the page. So they basically recreated ASP.NET in ASP.NET instead of just using ASP.NET. Whether or not you like the draggy droppy stuff, they ended up doing the same thing that those controls do. So the whole application was these 2 files, the web form with the content placeholder and all of that code and the code behind. And how the code was organized was even more interesting. So it was set up in regions because everybody loves regions. And this region would render a block of code here, and this region would render the little login box up in the top, and the next region would render, you know, a banner, and one region would have the code that rendered a sidebar. So you had to know what region to go into and to find the code and to go and add the controls. And it all looked at a query string. And this was like one of the longest query strings I've ever seen. And all this query string did was it passed a whole bunch of parameters to determine what should be built and a couple of security flags and all kind of other stuff. And that's all that it did. Now, this also ties back to that security flag field. So this was that same person doing this. And so it tied back into that, where they actually would have to go through with a bunch of SQL statements that ended up being hard coded, not even parameterized. So when an intern came in and he said, wouldn't this make SQL injection possible? We said, there's your first project, kid. Right? He actually was able to show how that would be possible. And so that at least got them to change some of that. But they had this code, and all they did was just dynamically generate everything with that much code. 120,000 lines should never be the size of a class file, because it's just ridiculous. Now, how's that for like the antitheses of SRP? Because that is like everything responsibility, which is what it was. So if they had just made a few patterns to follow with some web forms and used controls and a few other things, they could actually have built a very good product with that. I did see an insurance company out in California who did such a thing. They had a really, really nice web forms application. It was very speedy. It was easy to maintain because they set it up in such a way where they can use patterns. They even had tests and a separation of the concerns. You can do it in web forms. So, and I think any lingering web forms now probably does it like that. But many people have moved on to MVC and Razor Pages and other type of paradigms to help enforce those kind of concerns and the separation of them. So, yeah, working with this stuff, right? It's WTFs per minute, basically. It is really difficult to work on a code base like that. To both help them maintain that because it was live and running, and also to help get them out of that by writing new code as well in a separate code base to replace them once they got themselves into that deep of a problem. So once you actually have something this bad, it was slow, it was terrible, it was hard to maintain. Nobody could do anything without breaking everything in there. The rewrite was the appropriate thing to do, which I'm normally not somebody who runs around yelling rewrite everything, because once you start building software and you do go through the process of QA and all that other good stuff, you end up having some nice assets that if you were to rewrite them, you have to go through that again. So if we don't have to rewrite, we don't. But in this case, they had to. They just had to. It was just that far gone. So here's more of a fun one that was pretty easily taken care of. So somebody asked for some advice because they were doing model view controller, MVC, in ASP.NET. And so we know if we have an MVC pattern, generally the model is your classes and they represent your data. The controller would go after that model or view model and would fetch the data or call a service that fetches the data. Once it does that, it passes that data to the view and the view renders it. So it's a clear working pattern. But what somebody did was a little different, a little twist on it, a little roundabout twist on it. So a client may request through a route and it comes to a controller, right? So I go to maybe, localhost or whatever domain / employees to get all the employees. And the employees controller's index would run. So what that would do is actually go fetch data out of a database and then write out the file, write out that data as an XML file. And then on the server, and then it would write out the XML file, and then when the controller, instead of just passing the data straight to a view like a controller does, the view then would just simply be rendered as an empty view, and then a request being sent out, like with fetch, basically, like an HTTP client request to hit that XML file and read it in using JavaScript. So instead of just going from the controller to the view, they wrote it out to a file, then dropped the view down on the client, and then had that refetch it with JavaScript. So it was like this really roundabout way of doing it. And I said, you could just cut out the XML and you do a couple things. You could change that controller to an API controller, and then you don't have to worry about writing that to a file because you're taking that hit. Or you could just do it the more traditional way and have the controller pass data to a view and let it render it server side and send it down. So they just decided to go ahead and change to API controllers and then continue reading from JavaScript that way, and that worked out fine. But that was a little crafty, creative, different, unexpected thing. So, but again, you can follow the conventions and you should be fine, right? So if I do MVC or an API and then pick that up from JavaScript, you're fine. Don't need to actually write that out as a file. So this was not a complete train wreck, just a little bit off the beaten path. Here, this one was not me, it's a friend of mine. I just found this very, very amusing. A Ruby and Rails controller, he's working on it. That's VB code, that's VB.NET. It's all commented out. So the best I can guess is that somebody was taking some VB code and converting it to Ruby, and they commented some out and like maybe put it in there to do a parallel coding session with it or something. But it's just fun when you see stuff like that because you have no idea where it came from. Bug tracking. So here's another point of contention for developers. Too many places just don't even use bug tracking. They just throw up a bunch of Post-it notes and you're good. I've literally seen this in like Fortune 100 companies, and they just have Post-it notes, sometimes even on a bulletin board, which is better than around people's monitors. So it's like a who's on first skit with bug reporting. It's just going around and around in circles. You end up, somebody fixes the bug and then somebody else doesn't know it's fixed, and something else pops up and it might break something else. And there's no real way of tracking the relationships between bugs, what has been fixed, and what the status of things are. There are plenty of bug tracking systems out there. Excel is used in a lot of places. Don't use Excel. Like, go get Jira. Or I work for JetBrains. We have this great bug tracking called UTrack. We use it ourselves. It's pretty awesome for features, for bugs, for all kinds of stuff. Or, like I said, Jira, anything that's not Excel, that's not manual, doing your bug tracking. Also, developers are interesting when it comes to reporting bugs. You think we would know better, but I see this in our bug database all the time. Somebody will simply say something like, hey, I am trying to develop code in Writer and it doesn't work. Writers are .NET IDE. And okay, can you tell me a little more than I'm trying to develop a program and it doesn't work? Like, this tells me literally nothing, but we get stuff like this all the time, like every day. Somebody once, this was fantastic. Somebody once sent in a bug report and they took a screenshot. And when they took a screenshot, it was a literal picture of the screen from their camera. And I was like, this is fantastic, because somebody didn't realize that there's a print screen or a way to actually print the screen. So they actually took a picture from the camera. But most of the time, it's just that people say, this doesn't work, and they give you no information whatsoever, because you can read the minds of all of your customers all the time. You can't. So bugs, you need bug tracking. And when you submit bugs, you need to tell the other developers, what were you doing exactly? What happened exactly? What did you do to try to remedy or work around the problem? So you need to give all that information and any logs that happen if the product gives you any logs. So yeah, bugs are often a big deal. So be clear, be specific with bugs, and I hope that when you do get bugs reported, they're not so vague. Source control goes out of control. GitHub is awesome. I haven't had so many problems with GitHub, except that it doesn't matter how many times you try, you don't seem to be able to memorize all the commands for whatever reason. But no source control is becoming less and less popular. But up until even just a few years ago, I would still see a lot of companies with no source control. What they would do is copy and paste. There would be a network share, and people just copy and paste the latest version of their software to a network share. Don't do that. Use source code control. Because we have this thing that actually takes care of this very problem for you. But yet, people don't want to use it. There was a big consumer electronics company that I worked with that had some very improper use of source code control. I believe it's on the next slide. And an insurance company that had branching so far out of control, it was a bit ridiculous as well. And these were both, before GitHub was very popular, it was using either TFS or even Visual Source Safe was one of them. The biggest thing now I see with GitHub is like checking in stuff like somebody's trying to check in a VM. Don't, that's just too big and you don't need it. You don't need to check in developer tools or extensions and things like that. Just your code, and don't check in secrets and passwords either. But I have seen some crazy stuff. For example, this consumer electronics company, they called me in and they said, look, we have this problem. Every time we roll out something, or every time somebody leaves or moves to another team, and they had a lot of people that would move to different teams for different projects. He said, every time somebody does that, we lose a whole bunch of code. Can you come in and look? And I'm like, you lose a bunch of code, like every time. What? Okay, so I go and let me investigate. I start looking. What do you do? I'm asking them questions. Okay, let's get the source code control. How do you do this? What's your development process like? And they say, okay, so when we start our new project, we will set up a project in source safe. And they said, and then we'll, like, each person gets a file, not a feature or part of the app that we're going to get a file, right? And they check out the file, and that file stays checked out for the duration of the project. And then they check it in. And I said, why are you doing that? And they said, well, because if we check it in, then other developers can check it out. And I'm like, is there a camera pointed at me? Somebody playing a prank here. This is what source code control is supposed to do, right? And so I'm like, so wait, you're telling me you're worried that if you check a file in, another developer can check it out? And they're like, yes. And I said, okay. And this didn't occur to you that maybe this is how it's supposed to be? And they're like, why would it ever be like that? I seemed a bit upset about the fact that source code control is set up to be like that, which actually made me more perplexed. I'm like, okay. So I said, look here, I can solve your problem. You'll have to actually go along with it though. And they just had this paranoia about them. So, the technology is not the problem, it's the people. And they have this paranoia that, if I check in a file, somebody else can check it out. And what if they don't ever check it back in? So look, at some point you have to put some team discipline. You have to tell everybody, new rule, you check it in every day, at least once a day. Don't you dare go home without checking that code in. You're gonna have to do this. And they said, okay. So this was not the best project ever. So they had all this, they kept having like no history. They want to know why they didn't have history. I'm like, because you don't check things in. That's why checking it out doesn't mean it's tracking. That's what the check-in does. And so I said, look, here's what you need to do. I said, people, they don't even need to do this file thing anymore. You don't have to clutch a file. You can use a feature. I said, when you're done writing a bit of code, just check it in. And please don't fret at that point. Like, take some herbal tea or something. Like, just meditate, whatever. Just check it in. Let somebody else check it out and work on it. and then have them check it in. So make your law that at the end of the day, that code gets checked in, right? It can actually compile and get checked in. At this point, I didn't even care if it could compile. I'm just trying to get them to check in the code. And they kept trying it, and it took them several weeks where they just kept trying this. And they kept having this weird paranoia about checking in the code that they didn't want to do it. And people would keep not checking their code in at the end of the day for fear that they would lose it or that they would lose data. And I said, ironically, you are losing code when somebody leaves and you can't access it because they didn't check it in. And you don't have access to those resources anymore. So it was mostly almost playing psychologist at this point, trying to get them to really just, leave the baggage behind and try to get into a process where they felt safe and comfortable to actually check in the code. Now, if you use GitHub, this should not be a problem nowadays, right? Just, do that clone, you've got it on your machine, you could do a bunch of local stuff and then push it, and you're great. So that would probably work a lot better for them, but that was not an option at the time. And this was really, really difficult for them to mentally just to grasp the fact that they just did not want to let this team just had this weird thing about letting other people touch their code once they checked it in. And that was really difficult for me to try to get them to not do that. So they were kind of doing that, not without problems. You can get everybody to check in everything every day by the time that project was up for me, but I think I got them most of the way there. A large insurance company that did mortgage insurance had this is when I had this excellent web forms project going on. And this web forms team was super high functioning, and they had this really nice code. And they asked me to come in for this MVC project, right? So that web forms project was more legacy. And they said, well, this MVC project, while I was start working on the MVC project and I'm getting set up, I noticed a bigger problem than the MVC problems that they asked me to come and fix. The MVC problems were just standard, help us with a few things and help us work out a few patterns and whatnot. So that was just, regular old programming and consulting. But the larger problem that I ended up having to get a TFS specialist in for to help them with this, like an ALM person, is they had constant merge crises. So what they would do is dish out feature branches, and each developer would get one or more features. So I might get 5 features, and another consultant might get 5 features, and a team member might get 5 features. So usually about 5 each. So you have all these different features. And what would happen is they would have you check out a copy for each feature, and you would just work on that feature in that one copy of your checkout, right? That one checked out code, right? So I would have 5 separate instances of the code for the checkout. And I said, why are you doing this? I said, I only need one, and I can work on all 5 features in here and then just check it in as I need it. And they're like, no, you can't do that. You have to have the features. And then at the end of the month, when it's your turn, you check them in. And then the next person will check theirs in. And once everybody checks theirs in, then it goes to the merge department. And I'm like, the what? The what? The merge department, so that the merge engineers can merge all of the code properly and the merge manager can approve it. And I'm like, what? Wait, what are these? I've never heard of these job titles before. There's a merge department with merge engineers, and merge managers, right? And then I feel like Rod Sterling is inviting me right into the twilight zone at this moment. So then I have to have them explain this again, right? So we do have a merge department with merge engineers, the merge manager. So instead of just letting me, take a clone of code, work on it, and check it in as I need, and merge it myself, imagine as a developer, I may be able to do that. I probably should be able to do that. Nope, I have to wait, take all 5 of these branches that I have, and then just check them in at a designated time, and then let an actual merge person do this. And I said, well, that's one of your problems. One of their problems too And they thought this was from MVC, but it was not. It was, they said, look, they said it takes us like a month to actually package and distribute the software. How can we get that faster? And I said, MVC is not causing that. I said, this is causing that. I said, I don't even want to deal with this one. I'll deal with the MVC stuff as opposed to this. So I ended up getting some experts to help them with that. I said, you clean that up. I'll stick with their working on their MVC problems. But that's what they had. So if you ever see a job role for like a merge engineer, that's probably the company. So, and it would be in the US. So if you want to just do merges all day for other programmers. And so what would happen, you know, if I worked on features and I maybe touched something that somebody else did, that other merge person would have to determine which actually overrides which. So it ended up with little messes all the time that had to be cleaned up. Actually, lots of little messes that had to be cleaned up like that. So it was just horrible. And that's why it took them like a month to package the stuff. And they were trying to ship on a schedule. And they're like, why? We don't understand why this isn't working. I said, that's why it's not working. So definitely don't do this. Just use source code control in the way it was intended. You don't need a branch for each feature. Generally, with most source code control, you could just get one clone or one branch, work on that, merge it in yourself. You don't need to send it to have somebody else do that. Also, other stuff that I saw, the same, different project though, but that same company, they had a lot of tests commented out and then wondered why sometimes things didn't work when they were testing. And I said, well, you know, they run really fast, but it doesn't actually help you when the developers keep commenting out tests. So don't do that. If you're going to write tests. Don't comment them out. If you're going to do that, just don't write them. Don't pretend. Architecture. So this is, I love this place. This is, I think, is it San Diego or San Francisco? It's called the Winchester Mystery House. It has a door to nowhere. It is a labyrinth in which people, it's a tourist attraction now. And people get lost in here. There's little hidden entrances and all the stuff that you would find in a creepy, scary movie. And it's because this very rich, old, eccentric lady thought she was plagued by ghosts. So she built the house to confuse them. So hence you get things like doors to nowhere and like really crazy, terrible architecture. But for this house, it was on purpose. For code, not so much, right? We don't start out planning to make bad architecture. It just kind of happens. So some of these things I call the Winchester anti-pattern because I will see this in code, doors to nowhere. I'll look at code and if you trace it with like an analysis tool, nothing's calling it, right? So nowadays, there's a lot of great tools. Our own tools do this. They'll tell you when code has not been called or you have some dead code in there. But bad architecture is everywhere, just as bad as code. Some of the architecture that you see that is bad, right here. I don't even need to know what this is, but I can tell you this. That's probably all you need of this, right? So many times you have these giant database graphs and you don't need most of it. You only need a little bit. And I've actually seen many times something just like this, where they had tables and tables and tons of things, and they think that they need a lot, but they don't. So often you only need a few bits. When I worked at Microsoft, they did some research on applications and how people use them and what they do, and they found out that almost like 90-some% of the databases out there are under 10 gig, and even a significant portion of those are under a gig. So they're small databases and they only have a few tables. And the ones that do have tons of tables like this often don't necessarily need all of that stuff. We do tend to over-architect a lot of things. One such architecture I saw was with queuing. So when's it a good solution? It's often a good solution. So queues could allow us to have asynchronous products, and we don't have to worry about sporadic connections, and connectivity does not have to be perfect for us. So if I were to develop something, what I might do is I might use a queue if I knew that that were the case. Now, if I knew I were on a network internally and this network is up basically 99.9% of the time and it's high performing, it's internal, you don't need a queue. Maybe if it's internet or serverless or something, you may need a queue, right? But so highly connected systems, major metro areas, you might not need a queue for these things, right? Because you have the connectivity. It's mostly for async. So what I might do is something like this, right? A client, website, web service, or service layer, logic layer, and then your database and whatnot. So it's kind of a standard n-tier setup. Right? So it's something I'm doing. If I had like a nice internal enterprise app like that, this is probably what it would look like. Sure, you could go microservices now and all that good stuff, but a lot of apps, especially enterprise ones, fit into this model just fine, right? But I did see something that was, I think, meant to be like this, but it ended up not really. So it ended up being like this. So you'd have a client computer that would hit this website, and it was a B2B website, so any of their business clients would log in and add products to a cart. And then this website would communicate with the web service, which is what I would expect. Except from the web service, I would expect that to communicate with the database or other assets or whatever. But instead, for no reason, there was a message queue here. So this web service would drop off messages on the message queue. And then the second web service would pick them up off of the queue. And then it would take them and push them into a database that was on the back end. And then after it would do some processing, the web service would retrieve data from the database, push the data onto the queue, and then that first web service would pick that back up off the queue and then push it back to the website to render. And I'm thinking the queue and then this whole other web service were crammed in here, or the first web service. The two of these things did not need to be here because it could have just stuck with that standard architecture, right? The website, service layer, and then my databases. But instead they had the queue. And the problem was that this queue, it wasn't two queues, like an incoming and an outgoing. It was one queue. And what they did was whenever they wrote a message to the queue, they would put a little flag on it saying whether it was incoming or outgoing. So then when these services would read, it was kind of dependent on when they read. And sometimes they would get out of order and then we'd have to go and reset things to get it to work correctly, which was a little bit awkward. So I suggested well, you could get rid of the queue and you can get rid of that web service. And at this point, once they were hitting this website and a call was being made from the website to that first web service, latency is not an issue at that point for them, anybody who was using this. So they were all on the same network. So that was a little bit too much queuing, a little bit over-architected there. It worked, but it had kinks. Enough kinks to eat up enough programmers' time that it was costing them a bit, but yeah, definitely over-architected when, sometimes less is more. So, oh, yeah, I forgot to. That second web service is where all the security, any kind of security checks were, or any kind of actual logic, which I think should probably go up front so that you're not wasting a whole bunch of layers and then finding out there's an issue and then having to go back through all the layers again with something. So good times there. So it's not just us, not just the developers, there's UX as well. Do I need to say anything here? This was actually a mock-up of a program. It was like a Windows Forms program. This was the color scheme they went with. I actually can't even really look at this for very long because it hurts your eyes. Let me just say, if you build software that physically hurts people's eyes, you're doing it wrong. Just that yellow is not necessary ever. I can see a little bit of red maybe for a validation pop, but geez, that's a little ridiculous. This happens. I've seen this several times. This is just one example. This thing with the phone number, just let people type in their phone number. You know what, if they can't type in their phone number, maybe they shouldn't be on the internet. It's not your problem, okay? Just let them type in the phone number. Not to mention, this basically forces it to be a US phone number. Now, if you're only dealing with US people, fine, but you might not be, and then guess what? That's not gonna work. Here's another one. This is an actual screenshot. Don't do this. This is like, you look at this and you don't know where to start, right? You're like, do I type stuff in? What should I click next? There's a lot. There's just too much going on here, and it shuts people down. Same thing here. This is just a slightly nicer thing, and this is a very popular tool here. This is a bulk rename utility, right? And yeah, okay, like it'll do that, but maybe there's a little thing called progressive disclosure where you can just show a little bit at a time, walk people through like a wizard style. You don't need to just blast people with UI and information, even if it's not turquoise and yellow, even if it is nice looking, there's just too much stuff going on for people, and then they just kind of shut down. There was some research done. I actually worked a long time ago at Wise Snacks and Born Foods in the US, and the folks that actually went out to the supermarkets they made snacks, right, and chips and potato chips and pretzels and things like that. And they said, you know what? They said, we will only put X amount of different varieties on the shelves, because if we put too much, it overloads people. And the UI is the same way. If there's too much, it overloads people. So try to just disclose little bits at a time. We're not always the designer as devs. Sometimes we're UI, sometimes we're not. So it just depends on your role. Another one with the phone, people, but just let them type in the phone. Like, you don't need this, you don't need the drop downs. I don't even know what to say about this one. It's almost, I feel like somebody had thrown a bunch of testing data in here and forgot to take it out. That's the only thing I could come up with. Either that or somebody was high. That's the only other thing I can think of. Here's another one, like, whoopsie. Like, sure, password, you don't need to tell anybody the password is being used, and let alone who it's being used by. You just say, no, try another. First of all, who cares if you have the same password as somebody else, as long as you have a different email, and it's highly unlikely that this is going to happen anyway, unless it's not a strong password. So just, let password generators do their thing. This one is fun. Staples. For the company that has this little red button called the easy button, this I find very ironic. Right, where do I sign in? How about just a nice, very prominent and visible location to sign in, a little box with a username and a button. Instead of a where do I sign in? If you have to ask, that's not good. Oh, here's another one. So I had to do a mock-up of this one. This was from an insurance company in the US. And I think you should still be able to see the screen with the screen share, right? So this is a mock-up. This is basically how it worked. They had a Windows form application, and across the top were a bunch of tabs, and these tabs represented a menu. And you would pick one of these options on the tab, and you would get more tabs because they were using tabs as a menu. Pick another and you get more tabs and more tabs. You could see where this is going. Oh, yeah, maybe you thought that was going down still. Nope. Then they started in on the side until they finally got to this little bit of a window with some fields to enter. And then sometimes some little tabs for actual grouping and little command buttons. And this is a very prominent insurance company in the US was doing this as their UI. And they were using one of those tab controls to do this. And you look at each of these had like dozens of tabs. They did not realize that you could actually create menus and use menus. For whatever reason, I don't understand why they didn't get that. That is baffling to me. But they didn't. They just did not consider that a menu might have been a thing to use here instead of tabs. And then so what happened is on top of this is bad enough if you run this kind of thing as a standalone operation, but they put this on a server, a central server for their department, and a couple hundred people were supposed to use this app. So they put it on a server where this whole entire group of a few hundred people would get to it. And then they would have people use Citrix to like remote into that terminal. And then they would fire up this executable and they would get like a couple of tabs in and it would just bomb on them. And it's because they were loading up so many resources with each of these tabs that it just would bring down the app every time. So they had me come in, they said, our app just keeps crashing. We get like 5 people on here and it just dies and it just throws this weird error and we can't figure it out. And I was like, well, I think here's your problem. So I said, you have kind of 2 problems. One is, 3 problems. One is that this is a Windows Form app. So you can package and distribute to all those machines, which is what you should do. And then have the database on the back end. Not have everybody remote in and use the same program. I said, because there's problems you didn't even get to yet with that, with concurrency. I said, then another one is this UI is a mess, right? You need to move these into, you have to re-architect this UI, move them into menus. So you have that as an issue. I said, once you fix those things, then your third issue should go away, which is the crashing, because it's just not meant to work that way. But that's the way that they had it working. So they had tabs. This is actually not a UI problem. There is an English simplified. I just find it funny to US instead of the Queen's English. That just amuses me. So of course, good UX is adhere to norms. If you see menus, use menus. Has meaningful, accessible color and good contrast. So there's people who are colorblind and we forget about them and make big red and green buttons and then people can't see them. It has to be multi-input friendly as well, right? It's not just keyboard and mouse. There's tons of things that help with input, responsive. Don't confuse people. Don't physically hurt them. Clear and consistent navigation helps as well. It should be as intuitive as possible and it should help people. If it's important to users, it should be important to us. So there's some good UX norms for us. So even if you're not a UX person, which a lot of devs aren't, that's okay. You can still at least know these few things about how to make a good UX. At least we could usually say we know it when we see it. Like you know a terrible UX or a good one when you see it. At least there's that. So a little bit about the non-devs for the IT pros. So it's not a code thing, just another fun thing. So I had a client once that had a Novell server in a closet. So I often see this with companies. They'll have this little machine and it's in the corner and nobody touches it because it has stuff running on it. And it's important stuff. But after a while, people forget what it is, what that thing's doing. It's just that we don't touch that machine. It's important, but we don't know why. And I see this at companies all the time. Well, in this case, this was locked in a closet. It was in like a little tiny server room closet. And they moved the building from where they were at to maybe a few blocks away. So it was an easy walking distance. In the meantime, they forgot what the admin password or they lost it. And when they moved, then they realized, oh crap, we need that server. And then they were like, what do? We can't shut it down because we don't have the password. And we can't shut it down because they realized what it did and it did important things. So they actually kept the UPS supply plugged into it and put it on a little dolly and actually scooted it down the sidewalk around the corner to take it to its new home while it was still plugged into the UPS. So another reason why we don't want those anti-patterns of having like a little machine like the one with the access databases and stuff like that, because you may end up having to do this. If it's a couple blocks away, it'll work. But if you moved out of town, it's probably not going to work. Right? That's going to go down before you get to move it. But that was rather amusing as well. And then they called me and, can you rewrite this program? Because we have no idea what it does, where the code is. And we barely found this admin password. So So that's why I know about it. So I got called in to rewrite the program. Consultants, that's all I need to say about consultants, right? And the whole conning and insulting. But you see, as a consultant, as you see, I see a lot of this stuff, right? It's not necessarily all conning and insulting, but it is crazy, right? I do walk into crazy town quite a lot. And I see some things. I mean, yeah, I have to give people props for the fact that they're very creative in some of the things they come up with. They should not be doing these things because they, just suck out performance and make things horrible. But I have to say it is very, very creative. Recruiters also tend to be a bit of a pain for us, right? They think Java and JavaScript are the same. I've probably been asked this too. Do you know C pound? So if you ever get a call and they ask that, like, just click. The classic requiring 10 years of experience in whatever product that just came out last year. Right? So you see that a lot. So it's not just the devs. We have the UX people, the IT people, the recruiters. Our whole industry has a lot of train wrecks and a lot of crazy stuff in it. So not just picking on developers, but everybody else too, right? But yeah, a little bit of fun. So this is what I've seen at a talk before. I found this was rather amusing. If you want to keep those recruiters at bay, do something like this, right? Change your LinkedIn profile. If they can point out which is tech and which is Pokemon, then they're probably worth talking to. Actually, I couldn't tell you what the Pokemon are, but I could at least pick out the tech, and I assume the rest are Pokemon. So much new tech, though, you might miss a few of them as well. But these kind of things are very amazing. But this is our industry, and this is how it goes. So and that's all that I have. So I hope everybody kind of enjoyed that.